Let's solve this question now. Choose the group of polysaccharide. Okay, now children, when you talk about polysaccharide, what exactly are they? The moment you talk about polysaccharide, there are a few things that should immediately come to your head. One, it is a type of a carbohydrate. Okay. Second, what does, break the word. Poly means many. Saccharide is a term which was derived from the Greek term saccharine, which means sugar. Okay. So polysaccharide, it is made up of many units. Alright. So this is something that you need to immediately have it in your head. Now let's see the options. What you are expected to do is choose the group of polysaccharide. Okay. A, starch, glycogen, cellulose. B, sucrose, maltose, glucose. C, glucose, fructose, lactose. Or D, galactose, starch and sucrose. Now here's the thing, children. Some of you all must have had these examples by hearted really well. So maybe you will get this answer very quick. But in case you are, you thought I've done this very well, and towards the end you probably get this question and you're not really able to get the answer very quick. And when you talk about an entrance, coming to our answer quick is very helpful. Okay. So what we're going to do is, all of these that you observe, all of these that you can see on the screen right now, they're all sugars. Let's discuss what are they. It will be a good recap for you all also. Take a look at this flowchart. Can you see this? Great. Now, when you talk about carbohydrate, as the flowchart says, the three basic ones are polysaccharide, disaccharide, monosaccharide. Mono stands for the single unit, a single sugar. Disaccharides talk about two, di two, and poly is many. You can see the examples here, so I'm sure you must have come around the answer. But here's the thing. If in case you were given this question and if in case you were very well prepared with at least monosaccharide, maybe not all the examples make a very good easy space in your head. Look at monosaccharide. Try to by heart the monosaccharides at least. See what is it? Glucose, galactose and fructose, isn't it? Now here's the thing. Imagine that glucose, galactose and fructose, they are all sugars trying to encourage each other. So they are monosaccharide, right? They still have to become bigger. So imagine all these monosaccharides are waiting together to get accumulated with each other and then become bigger polysaccharides or disaccharide or anything. So these tiny little monosaccharides are all grouped together and they are encouraging. The moment they are picked up, they are encouraging each other. How are they encouraging? By saying, go friends, go. Okay, go friends, go. So G stands for glucose, F will be your fructose and G will be your galactose. Keep saying, go friends, go. Now here's the thing. If you were aware about these three at least, you could have used something called as elimination method and removed the options which had monosaccharide. Because your question wants to know that three sugars that they have given as a group, all three have to be poly, correct? So let's see how. You already know now, go friends, go. Glucose, fructose, galactose. These are monosaccharide, correct? And your question wants to know polysaccharide. Let's see if you can find these monosaccharide in your options. So look at option number B. Can you see glucose? Monosaccharide. So obviously this option will be eliminated. No. C also has glucose and fructose also. And then D has galactose of the go friends go. So what is left? A. A is your correct answer. And how long did you take to come to this answer? If you knew what the monosaccharides are, hardly a few seconds. Okay. But having said this, does not mean that we are going to throw all these options away. We will discuss them because they can also come as some secondary question. So let's take a look at the examples in detail. Disaccharides. Common example of disaccharides, maltose, lactose, sucrose. Now if you observe maltose, it is made up of 2 glucose units. Okay. And if you observe all the disaccharide, glucose is quite a common link, isn't it? Now, if you want to recollect what is maltose, imagine glucose is sitting and then he uses the word M for maltose. So glucose says me, M for me, M for maltose. So glucose and glucose will give you maltose. Then you got lactose. Glucose is a common unit. Lactose, the word galactose in itself is saying lactose. And finally sucrose. Observe in these disaccharides, as of now, have you come across anything with a letter R? No, right? So you've got sucrose has a R, fructose also has a R, but nobody else does. Okay, so sucrose, glucose is a common one, and fructose. Sucrose is made up of glucose and fructose. Easy? Or fructose. Clear? Finally, you've got polysaccharides which have cellulose, which is forming a structural component of the cell wall of the plants. Starch, which is the storage form of food or stored food for plants, and glycogen, stored food for animals. All three of them are made up of glucose. Okay, but then here's the thing. If you see, there's beta D-glucose and alpha D-glucose. So these terms will come into picture with respect to certain position of the molecules or of the groups which are forming that particular compound. Okay. So as of now for this question, please remember these examples. Okay. Examples by default, there is no other option. You have to remember them. Use tricks. So you get these examples quite quick when you're solving a question. Okay. Now sum this answer up, everyone. Monosaccharides are made up of monosaccharides are glucose, galactose, fructose, as you see this. Disaccharides are maltose, lactose and sucrose. Finally, polysaccharides are what? Cellulose, starch and glycogen. Okay, keep them in mind. It's very important and they can be asked as lateral questions somewhere or the other. Now, this is a very easy one, everybody. Let's try this. Which one of the following or which of the following is a heteropolysaccharide? Saccharide, it's a term derived from the Greek word saccharine, which means sugar. Poly, many, and hetero means different in simple terms. So when you say different types of, many yet different types of sugars or units which is found in this compound. Okay. Now, what are you looking at? You're looking at a heteropolysaccharide. Is it A, peptidoglycan, B, starch, C, inulin or D, chitin? And the answer for this particular question is option A, peptidoglycan. Now, where is peptidoglycan? It is found in the cell wall of bacteria. We'll discuss that one by one. Let's take a look at this flow chart. Now, if you observe this flow chart carefully, you can see polysaccharides. And what are polysaccharides? They are a type of carbohydrate. Polysaccharides are of two basic varieties. Homopolysaccharides, because it's poly, many units are there. So, homo means all the units are same. And heteropolysaccharide meaning many units, it's hetero. They are not all same. Alright. Now, the common example for heteropolysaccharide, peptidoglycan and agar. Peptidoglycan in the cell wall of bacteria, we'll see the structure. Agar, it's a polysaccharide which is obtained. Generally, you must have come across algae. Algae have secrete, some of the algae secrete these agar, which is a polysaccharide. Now, what I would strongly suggest is make this flow chart. Of course, make the variations of homopolysaccharide also and paste it very, somewhere where you can frequently cross this. Pictorial memory helps the best in recollection. Okay, so you just crossing through. Don't sit there to by heart or learn. Look at it every day. Look at it every day. You will be so surprised that you will remember this information for a very long time without even attempting to by heart it. Okay, just try that. Now, let's talk about the other structures. We saw starch being mentioned there. And starch, if you see, are of two variations. One is amylopectin and another is amylose. If you observe, they are both made of glucose only. So, the unit is same. They are homopolysaccharide. However, amylopectin and amylose, they differ in the way these chains or these units are placed, branched and unbranched. So, there is a variation in their structure which obviously reflects in their chemical nature also. You don't have to remember all that detail, but you need to just observe they are different. Now, further when you take a look at chitin and inulin. Chitin, if you observe again, students, it's glucose. It's made up of glucose. But what you're seeing is something that we call as a derivative of glucose. Okay. So, this derivative of glucose will include NAG and NAM as a name. So, we're gonna see that also in a while. But before that, also take a look at inulin. Now, inulin happens to be fructose. Again, same unit. So, what is it? It is a homopolysaccharide. Wonderful. Now, when you talk about glucose again, we're going to see NAG coming in. A derivative of glucose, NAG. Alright. N-acetyl glucosamine. So, they're also same. That's why you'd use the term homopolysaccharide for chitin as well. Clear? And then finally, peptidoglycan. As you see, they are made up of two different units, NAM and NAG. NAG stands for N-acetyl glucosamine. I'm going to give you the spelling, don't worry. And N-acetyl muramic acid. Let's see. Polysaccharides which have the same repeating units are called homopolysaccharides. Starch and cellulose are homopolysaccharides formed of the repeating units of glucose joined together by glycosidic bonds. Remember the name of the bond, very important. Chitin is a homopolymer of N-acetyl glucosamine. N-acetyl glucosamine, which is a derivative of glucose. So if you see the structure here, you may see glucose, but if you observe the arrangement, you will see it's not exactly same because it is a derivative of glucose, N-acetyl glucosamine. Okay. Further, inulin is a homopolymer of fructose. Heteropolysaccharides are polymers of more than one type of a repeating unit. An example is peptidoglycan. It is a polymer made up of repeating units of N-acetyl glucosamine and N-acetyl muramic acid, the NAG and NAM. Further, take a look at the wall, students. If you observe, it's this part of the cell wall, if it's magnified and you take a look at the molecular composition or what it is made up of, you observe that it is a heteropolysaccharide which has got it is made up of two different units predominantly, and that is NAM and NAG. And that's why this is a heteropolysaccharide. Now let's try this one, everybody. Cellulose. The most important constituent of the plant cell wall is made up of a unbranched chain of glucose molecules linked by alpha 1,4 glycosidic bond. Now why do you use this 1,4? Why are these numbers used? Because when you're forming bonds between two molecules, you have to take into account which carbon is forming that bond. So first carbon of one molecule, fourth carbon of the next. So if you come across a number like 1,6, you are talking about the first carbon of one molecule and the sixth carbon of the next. So having said this, let's continue. Is it option B, branched chain of glucose molecules linked by a beta 1,4 glycosidic bond in the linear chain and alpha 1,6 glycosidic bond at the sites of branching? C, unbranched chain of glucose molecules linked by beta 1,4 glycosidic bond, or D, branched chains of glucose molecules linked by alpha 1,6 glycosidic bonds at the site of branching. Now before you come to the answer, before you select the option, let's just have a quick recollection of how does cellulose look. The first thing I want you people to observe is it branched? Can you see anything which is going upward or downward? No, it's a linear structure. It's an unbranched structure. So what you can do is eliminate the options which included the term or description of being branched, and that would be option B, that's not right, and option D, which is also not correct. Then further, what about the alpha and the beta term? So we know that we have finally decided that, and we know that cellulose happens to be an unbranched structure. Now what you need to understand is whether it has an alpha or a beta linkage. To understand that, you need to take a look at the structure. Now what you're looking at are both glucose molecules. Here I had the carbon out so that we can count it, and in this structure what we can see is identify or notice a difference. They're both glucose molecules. See this. First let's number the carbon. 1, 2, 3, 4, 5 and 6. Okay. Now what I want you to do is observe, now correspond the first carbon to this next one. If this is the first carbon, naturally here is where your carbon is, the first one. And you can go on 2, 3, 4, 5 and 6. So this is how you're going to number the glucose molecule. The next thing what I want you to observe is the hydroxyl group on the first carbon. Where is it? if you look at it, here it's down and here it's up. When it's down, you come across the term alpha, and when it's up, you say it's beta. Easy? So what I want you to do is observe the structure again. Just this area, the bracket. Now in the bracket, try to look for that first carbon, the first thing. So we know the one which was beside oxygen, that happened to be the first carbon. Okay, so if this first carbon is here, where is your OH? And if you try to look, the OH is missing. You only have the O. Why is that H missing? Because that H participated in forming the bond. It was lost as a molecule of water when the bond was formed. But the O present up indicates that OH was up. So this is alpha or beta? This is beta. Okay. Now if you observe the entire structure of cellulose, you can see that to form the entire structure, the molecule of cellulose tends to flip. Say that's why you can see the O is here sometime and then the O is here sometime. It's flipping. Okay, of course this flipping adds to its structural advantage, but what you need to do is pick the answer. What is the answer? One, we know it's unbranched, then we know it's between the first and the fourth carbon, which we'll count again, and then you see it's alpha or beta. Which one was it? Beta, correct? So that's your correct answer. Option C, unbranched chain of glucose molecules linked by beta 1,4 glycosidic bond. Easy. Let's just get this final, alright, let's just get this final count on 1,4. Okay, listen to this. This is your first carbon, second, third, fourth, fifth and sixth. Name number here also. First, second, third, fourth, fifth, sixth. So can you see it's between the first and the fourth every time? First and the fourth. Easy? Now let's get into the small description of this. Cellulose is an unbranched homopolymer made of repeating units of glucose linked together by beta 1,4 glycosidic linkage. Amylose is an unbranched chain of glucose molecules linked by an alpha 1,4 glycosidic bond. So alpha, where was the OH? Down. Amylopectin is composed of branched chains of glucose molecules linked by an alpha 1,4 glycosidic bond in linear chains and alpha 1,6 glycosidic bond at the site of branching. So these were your options which were given along with the other questions. Okay. Please remember the structure. Note down how can you easily get the difference between beta and alpha. Okay, so this is a simple one. Most animal lipids are composed of dash fatty acids, whereas most plant lipids are composed of dash fatty acids. Now this is a very, very important question, children. You need to be aware about the concept on this. Now the question is very simple, okay. Are most of the animal lipids, are they composed of unsaturated fatty acids, whereas most plant lipids are composed of the saturated fatty acids? So you please make sure you number your blank well. So here you got this is blank number 1 and blank number 2. Okay, make sure you don't go wrong here. And then you start subsequently adjusting it. Okay. So are animal, as per option A, are animal lipids unsaturated and plant lipids saturated? Okay. B, it's the other way. B, is it animal lipids are composed of saturated and plant lipids are composed of unsaturated? C, both are saturated, animal as well as plant lipids. Or D, it's both are unsaturated. Okay. So here what you need to be aware about it is very simple. There are some concept which will be applied, but then you don't have that extreme detail of understanding the chemistry of why exactly and how exactly it is. So luckily you just need to remember what is the saturated and which is the unsaturated. Now here's the difference. What is saturated first of all? The ones which will all have it. Basically in chemistry you must have seen a lot of detail between saturated and unsaturated, the term, especially in case of hydrocarbons, isn't it? Now here when you see unsaturated or saturated, it's just keep it simple. Saturated, single bond, unsaturated, double or more, correct? Now, take a look at this. If you see ghee, okay, ghee is, in a basic Indian household, ghee is one of the most important, product that is used. So, ghee, if you look at room temperature, I'm not talking during summer season or during rainy season or the winter season or any other seasons. Just a normal room temperature, you will observe that ghee will remain solid, okay. Whereas if you take a look at oil, the ones that you get from, you must have seen sunflower oil, mustard oil and all oils that you get from plants, they will be liquid at room temperature. Now, don't think that, okay, if I go to a very cold region and there when I had gone, we were trying to get the coconut oil out and it was all jammed, it was solid, but that was not room temperature, right? So, it's too low. So, at a particular room temperature, specifically when you talk about room temperature, observe what is the state of the ghee, animal fat and oil, that is a plant fat or plant lipid, correct? So, what you get to see is animal fats, they are solid at room temperature because they are saturated. Plants are not solid at room temperature, they are liquid because they are unsaturated, okay? So, what is your answer here, children? Animal lipids are composed of saturated because they are solid and plant lipids are composed of unsaturated fatty acid. So, what is your answer? B. Okay, they are not same. So, definitely not the same. Okay, but animal fats are saturated and plant lipids are not saturated. They are in liquid temperature. Let's just sum this up. You can write down a few points in case you think you missed it. Animal lipids or fats are mostly composed of saturated fatty acid. Please remember this line. It is a very important statement. Okay, animal, solid at room temperature, saturated. You need to remember all three. Animal, saturated at room temperature, solids. Easy. Next, saturated fatty acids are solid at room temperature. They do not have a double or triple bond between the carbon atoms. So, they have a single bond. Okay. And ghee is an example of animal lipid or animal fat. Easy. Now, next, plant lipids or oils. They are mostly composed of unsaturated fatty acid. Now, what are those fatty acids? You got oleic acid, linoleic acid, linolenic acid. All important. They are very important, okay, for your diet, for your food consumption. You need them. They are generally liquid at room temperature and have double or triple hydrogen bonds between the carbon atom, okay, and then along with a single bond in their structure. That's just structural chemistry, but you will still see a double or a triple bond. Next, example of plant lipids or oils are sunflower oil and mustard oil. You will get so many, coconut oil, castor oil, right? So, these are all plant extracts and they will be unsaturated liquid at room temperature. Remember that, it's very important. Okay, so let's try this one now. A complex polysaccharide produced from sucrose by the bacterium Leuconostoc mesenteroides is, now what is this Leuconostoc mesenteroides? It is a lactic acid bacterium, okay, now which basically is involved in fermentation processes as well. Now, what are your options? A, chitin, B, starch, C, cellulose or D, dextran. Now, here we'll have to give you a direct answer, children. Here the answer happens to be dextran, okay. So, what is produced? The answer is dextran. Now, let's discuss. If you take a look at, if they have mentioned chitin and all, what exactly is dextran? Like there are lots of polysaccharides or polymers made by, adding more and more monomeric units, like you can see with chitin. Glucose is added, and, in a specific pattern, you get chitin. Now, what is dextran? Dextran is also a polymer or a long chain of glucose molecules. I'm trying to simplify it, but the molecular weight is very, very low. Okay, so that's where the difference is. Now, cellulose again, if you observe, like it was mentioned in the options. Look at this. This is also a polysaccharide or a long chain of glucose molecules. Now, starch, if you observe, the next one, you can see it in two fashion. One will be a branched and one will be an unbranched version. So, the branched version is amylopectin and the unbranched version will be amylose, okay, again made up of glucose. So that is also made up of glucose, glucose, glucose. The monomeric units are glucose. Even in dextran, the monomeric unit is glucose. So what I would suggest is you can sum this up and write this down, children. Dextran is a low molecular weight polymer of glucose. Okay. It is produced by the bacteria Leuconostoc mesenteroides by fermentation of sucrose. Okay. Please remember this. This also probably can be put as some other question. You never know. Be prepared. Chitin is a structural homopolysaccharide. Homopolysaccharide because all the monomeric units are glucose, 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 glucose. Same. Correct? Next. Why do you use the word structural? Because it is a part of the structure of the cell. Okay? It's not accumulating or storing things. Next. So, chitin is a structural homopolysaccharide that forms a cell wall of fungi and the exoskeleton of insects or arthropods. Next. Cellulose is also a structural homopolysaccharide that constitutes the cell wall of plant cells. Something that you must have read so many times by now. Next. Starch is a storage homopolysaccharide found in different parts of plants. Indeed, isn't it? And you already saw amylopectin and amylose about starch. Remember that, it's very easy, and you need to remember the examples. Okay, you need to know chitin, cellulose, starch, the type of starch. That will help you a lot for such questions.